Alright, so how is reactive distillation different from traditional distillation? Well, with traditional distillation, typically we're assuming that we're only trying to do a physical separation of compounds. So there's no reaction going on here in our distillate flask. We attach it and we take the vapors off and we transfer the vapors off to the other side and we're trying to get purity. Now, with reactive distillation, typically what we're trying to do is drive a reversible reaction. So something like ester formation. We have something like carboxylic acid with an alcohol and we're going to produce a water and an ester. Well, this is a reversible reaction. So if we just had the flask, one way we could drive the forward reaction is to add something like a chemical that would absorb out the water. Now, that's not a bad idea necessarily, it's just that it's going to produce waste. Now, what we can do instead with reactive distillation is that because of these different compounds, the ester, the alcohol, the carboxylic acid, and the water all have different vapor pressures, in principle, we can distill off the undesired water, particularly if the water has a lower boiling point relative to the other compounds in the mixtures. And this is usually typically true. The ester is going to have a higher boiling point than the water simply because it is a much heavier molecule. So, with reactive distillation, we're doing a few things here. One, we're driving off one of the final products to drive, by Le Chatelier's principle, the forward reaction. The second is that if we were really pretty good about judiciously picking our reaction system, we'll also get a degree of reflux too. So if something like in-butanol is reacted with acetic acid, those both have volatilities lower than water but higher than the ester. Well, if we use something like a fractionating column, a lot of the water is going to come off because our fractionating column is going to ensure we get good separation of the water from the lower vol, heavier compounds. And the butyl alcohol and the acetic acid are actually going to come back down. They're going to reflux back down the distillation column. And so we're going to drive the forward reaction not only by removing the water, but also making sure we have high concentrations of the starting products. So this is how your reactive distillation is different than a traditional distillation. We're using the distillation to do two things. One, we are using it for separation like before, but we're using it to remove an undesired forward product to drive the forward reaction. And second, if we're very judicious about this, we're also using this as a way to do refluxing, basically allowing us to drive up the temperature of the reaction and drive the forward reaction.